Welcome back, everybody. This lesson is going to cover kind of the ins and outs of expressions, what a coefficient is, what like terms, what are constants, kind of just basic vocabulary, and some of the foundations of what you're going to need to know moving into algebra. These notes can be copied or written in your journal. They can be found in your learning module, and it's important that you go through all this vocab before you start your lesson so that you know what you're dealing with. So the first thing that we want to talk about is just kind of, let's fill in the blanks here. It says each part of an algebraic expression is called a what? It's called a term. We call them terms. The numerical factor of a term is called a coefficient. Let's say you have an algebraic expression like 3x plus 1. 3x is your term. So is 1. 1 is also a term. But 3 is considered your coefficient. 1 is something else. I'll get to that in just a second. But the number that's attached to the letter x, to the variable x, is called the coefficient. Now, if an expression contains the same variables and powers, the terms are called like terms. So here are some examples of like terms, like if you have 7x and negative 2x. Those are like terms because they both are attached to an x. All right, never mind that 7 and negative 2 are different coefficients. The fact remains that the x's are the same. All right, 5, 2, and 3.4 are considered like terms because they're all just basic numbers. They're called constants, which we're going to get to. Those are like terms. Those all can be added up. You can add 5 plus 2 and get 7, and then 7 plus 3.4 is going to be 10.4. And then in kind of a real-life example here, you can say that 9 inches and 5 inches are like terms because you can add them up, 9 inches plus 5 inches. If I wrote 9 inches and 5 feet, you couldn't add those necessarily. You couldn't say, well, 9 inches plus 9 feet equals 14. Well, 14 what? Do you call that 14 inches? Do you call that 14 feet? Well, it's neither. You'd have to convert 5 feet into inches and then, or just combine it and just say it's 5 feet 9 inches. Now next, if a term does not have a variable, it's called what we call a constant. Okay, constants don't have a letter attached to it. They could just be basic numbers, like 1 is a constant. They could be fractions too, like 1/3, or decimals, 2.5. Those are constants. As soon as you attach a variable to it, like if I write 8n, well, that's not a constant. That would not fall in that category of being a constant. So 4 plus 17.03 are like terms because those are both constants. Constants can be added to other constants, of course. They don't have to be necessarily whole numbers. They could be fractions. They could be decimals as well. And it doesn't have to be addition. It could be subtraction as well, like 9 minus 2. Of course, you can subtract those and get 7. There's nothing wrong with doing that. Now in this exercise, what we're going to do is we're just going to kind of break everything up into terms. What are the terms? What are the coefficients? Among all the terms, what are the like terms, if any? And what are the constants, if there's any? Sometimes there might not be any like terms. There sometimes might not be any constants. So the terms basically are everything. Negative 4x is a term. 12 is a term. The constant 12 is a term. And x is a term. The coefficient is the number that is the factor of a variable. So if you're looking at this term right there, negative 4x, the coefficient is negative 4. Not negative 4x, but just negative 4. Now 12 is a constant that does not count as a coefficient. And then this is where it gets a little bit tricky. But when you have just a lone variable, you can always imagine, and one thing you might hear your math teacher say a lot is that there's a lot of invisible ones in math. And this is one of those instances where there's an invisible 1 there. You know, there's a 1 right in front of that x. You can always kind of by default put a 1 there. The other coefficient in this expression is 1. The only coefficients in this problem were there. That was it. Now the like terms are the things that you can either add or subtract. So let's see. Can we add negative 4x plus 12? No, because those are not like terms. This one has an x. This one does not have an x, so those would not be considered like terms. So the like terms here are the x terms right there. So we've got negative 4x, and we have positive 1x. And sometimes I encourage my students to just write 1x. If it's just a lone variable, it's okay if you just write x. It's kind of a good thing to do, especially if this is something that's new to you, or if it's difficult for you to imagine that there's a 1 there. Just go ahead and put a 1 there. I can't imagine there's any math teachers out there that are going to be against you doing that. And then the constants are the terms that don't have a variable attached to it. So the only constant in that expression is 12. Okay? So that one I spent a little bit of time on because we were kind of explaining every bit of it, but now we can kind of go more quickly through some of these. So the terms in expression B, we have an expression 6n minus 7n minus 4 plus n. And again, if you want to, when you just have a basic variable, nothing attached to it, there might not be a number in front of it, you can by default put a number 1. You know, me personally as a teacher, I never find any fault when students do that. I think that's perfectly acceptable to do that, especially when it helps you understand that there's a 1 there, because a lot of times it's overlooked if we don't put a 1 there. So the terms, we have 4 terms here. We've got 6n, we've got negative 7n is a term. Now notice I'm including the sign that is in front of the coefficient as part of the term. Now that term right there is negative 4, not just 4, but negative 4. And then we also have 1n. So we have 4 terms in there. Now the coefficients are the numbers that are in front of the letter. So 6 is a coefficient. Negative 7 is the coefficient of n. So negative 7. That is not a coefficient. And the coefficient of just n is 1. So there's 3 coefficients in that example right there. Now the like terms are the things that you are allowed to add. So in this one right here, 6n can be added or subtracted to anything else that has another n. So this also has an n, so negative 7n, and positive 1n. Right there. So there's 3 like terms in this example right here. 6n, negative 7n, and 1n. Now, you don't have to worry about adding them or subtracting them. We're just kind of right now just putting them down and making sure we know what part of the expression is what. And then the constant is the number that does not have a variable attached to it as a factor. So the only constant in example B is negative 4. In example C, we have the expression 9y minus 4 minus 11y plus 7. All right, so we have 4 terms. We have 9y, we have negative 4, that's a constant. We have negative 11y, that's another term. And we have the constant of 7. The coefficients is the number that's a factor of the letter. So 9 is a factor of y. So 9 is a coefficient. That's a constant. The coefficient of this y right here is not just 11, but negative 11. And that's a constant right there. Now the like terms, you might notice there's more than one pair. So for this one, 9y and negative 11y are like terms, as well as the constants, negative 4 and 7. For that particular example, we had 2 pairs of like terms, meaning you can add or subtract negative 4 and 7, and you could either add and subtract 9y and negative 11y. And the constants here are negative 4 and 7. Now for example D, why don't you go ahead and try this one on your own, pause the video, list them out, and then see if everything kind of matches up with what I get. Okay, so see if everything matches up with what I have here. There were 4 terms. There was 8D, there was 2F, there was negative 10, and there was negative 3x. The coefficient of 8D was 8. The coefficient of 2F was 2. And the coefficient of negative 3x was negative 3. Now the like terms, this is the first example here where we didn't have a single set of like terms. There was no pairs or trios to put together. There was no like terms because the only thing you can add to a D term would be another D. The only thing you can add to an F term would be another F. The only thing you can add to a constant term would be another constant. The only thing you can add to an X term would be another X. And the only coefficient of that expression was negative 10. Now the next part of our lesson involves us kind of taking all that information we just learned and now let's apply it. We want to be able to simplify expressions. And now simplifying expressions, a lot of times it throws people off, especially that word simplify. But don't be thrown off by that word simplify. It just means kind of put together as much stuff as you can in an algebraic expression and try to narrow it down to as few terms as possible. So an algebraic expression is in what we call simplest form if it has no like terms and no, I know I only have one spot here for this, but no like constants, which are the same thing as like terms, but kind of put that in there. And then use what we call the distributive property to clear parentheses. Okay, now in this first example right here in the practice problem, we've got write 4D plus D in simplest form, and then it goes around to ask the question, what's another way to express the D term? And now if you were paying attention before, you might have noticed that another way to write D would be writing it as just 1D. It's a good idea to remember that the coefficient, if it's just a letter, if it's just a variable, then it's okay to know that there's a 1 there. So 4D plus 1D is a great way to think of it because then it's easier to add those up. So now you just add the coefficients. 4 plus 1 is going to be 5D. And that's it. That's all you can do. A lot of times when you're dealing with algebra, especially when you're dealing with expressions, your answer might look like it's still a math problem, but we are through. This is simplified. All right, there's nothing else we can do with that unless we know what the D term is, but right now that's not important. We just want to know what the like terms simplify into. Okay, in this next example here, we're going to write 9h minus 2 minus 7h plus 6 in simplest form. So we're going to follow those rules that we can only add like terms with other like terms. So the only thing you can add to 9h would be 7h. Well, that's negative 7h because I'm going to pay attention to the sign that's in front of it. So you have 9h and 7h. Now when you put that together, 9h minus 7h is 2h. You're going to subtract those. And then we're going to add constants with other constants. Those are considered like terms as well. So you have negative 2 plus 6. Now negative 2 plus 6 makes 4. So then we're going to write plus 4. And then that is it. You are through with that problem. I know, again, just like I was saying before, it looks like another math problem. It absolutely does. 2h plus 4, looks like we have more to do for sure. But we're done. If all we had to do was put it in simplest form, we've done our job. We've got it in simplest form. 2h plus 4 does not make 6h. That's like, for example, does 2 inches plus 4 miles equal 6 inches? That makes no sense. Or does it make 6 miles? No, that doesn't make any sense either. So that's why those are in simplest form. You couldn't add 2 inches plus 4 miles. You couldn't add, does 2 nickels, plus 4 quarters, does that equal $6? Does it equal 6 quarters? Does it equal 6 nickels? No, 2 nickels and 4 quarters is just what it is, 2 nickels plus 4 quarters. Now for this next one here, we're only going to put like terms together. So for this one, we've got 4x, and right here we have negative 4x. Now that right there, that's called the additive inverse. Now additive inverse means that those cancel each other out. 4x minus 4x means they have now canceled each other out. There's no x. Now I'm not going to write 0x. I don't want to write that as part of my answer. There's just no x's left. I mean, if you wanted to, I guess you could put 0x, but it's a little unnecessary. And then we're going to add constants or subtract or add constants with other constants. So negative 11 plus 5. So negative 11 plus 5 is going to make negative 6. And we are through with that problem. Negative 6 is our answer. Now, some people might write negative 6 plus 0x. I guess that's okay. That's all right. But it's a little, like I said, it's a little unnecessary to have to write that. If we're putting something into the simplest form, we want to get it down to, we want to narrow it down to as few things as possible. So negative 6 is what we're really looking for here. And then in this last example right here, we're going to only add n's with other n's. So is there any other n's? I don't see any. All right, are there any other constants? I don't see any other constants either. Are there any other p's? No, there's none of those. So in this example, sorry to confuse you here, but this is going to happen. But in this example right here, it is already in simplest form. You got 8n plus 4 minus 3p. That's all you can do with it. I know we didn't do anything with it really, but that's how it sometimes goes. You know, just like when you have a fraction, like 16 over 25, and it seems like it should reduce, but it doesn't. 16 over 25 is in simplest form. And sometimes fractions will turn out that way, just like expressions will. Okay, so that does it for your lesson. Make sure you do the practice problems that accompany this lesson, and everyone have a great day. See you later.